The question is, if u is equal to log of x cube plus y cube plus z cube minus 3xyz, then prove that del x plus del y plus del z whole square of u, which is equal to minus 9 upon x plus y plus z whole square. This is one more example of partial derivative of u with respect to x, y, and z. So now here, instead of two independent variable, we have three independent variable x, y, and z, and u is the only dependent variable. We have given that u is equal to log of x to the power 3, y to the power 3, x to the power 3 plus y to the power 3 plus z cube minus 3xyz. Let us first find what is the partial derivative of u with respect to x. Then we have to prove that del x plus del y plus del z whole square of u is equal to minus 9 upon x plus y plus z whole square. Differentiating one partially with respect to x, we have now just look here, this is log of something. So log of x, what is the derivative of log of x? It is nothing but 1 upon x. So here x is, this total term is x. So log of this is 1 upon x cube plus y cube plus z cube minus 3xyz. And then again, derivative of x cube plus y cube plus z cube minus 3xyz. This is called chain rule. So partial derivative of u with respect to x is 1 upon x cube plus y cube plus z cube minus 3xyz into partial derivative of x cube plus y cube plus z cube minus 3xyz. Now let us try to take the partial derivative of x cube with respect to x is nothing but 3x square. Since x, y, z are independent, so partial derivative of y cube with respect to x is 0. Partial derivative of z cube with respect to x is 0. And now here 3y, z, these are constant. So partial derivative of x with respect to x is 1. So we have 3y, z. Hence, the partial derivative of u with respect to x is 3x square minus 3yz divided by x cube plus y cube plus z cube minus 3xyz. Similarly, if we will try to find out the partial derivative of u with respect to y, what will happen? This will be 1 upon, same thing we had, 1 upon x cube plus y cube plus z cube minus 3xyz. And instead of this x, it will become y. So derivative of x cube with respect to y is 0. This is 3y square plus 0 minus 3xz. So what is the partial derivative of u with respect to y? This is 3y square minus 3xz upon this term. So only this term 3x square minus 3yz is converted to 3y square minus 3xz. And similarly, we are also able to get what is the value of del u del z. Similarly, del u del y is what? 3y square minus 3xz divided by x cube plus y cube plus z cube minus 3xyz. And the same thing, what is the partial derivative of u with respect to z? This is 3z square minus 3xy. Just look here. Here, if you want to find with respect to y, y is not y here. Similarly, if you want to find out with respect to z, only xy will present, z will be absent. Denominator is always same for the all three cases. Now let us try to add all these things. So del u del x plus del u del y plus del u del z is equal to 3x square minus 3yz upon x cube plus y cube plus z cube minus 3xyz plus 3y square minus 3xz upon x cube plus y cube plus z cube minus 3xyz plus 3z square minus 3xy upon x cube plus y cube plus z cube minus 3xyz. This is very, it is very clear, it is clearly the denominator of each and every term are same. So LCM is x cube plus y cube plus z cube minus 3xyz. And in the numerator, we can write down 3x square minus 3yz plus 3y square minus 3xz plus 3z square minus 3xy. Now here, just look here. 3 is common in each and every term in the numerator. So we can take 3 outside. So x square plus y square plus z square minus xy minus yz minus zx. So we can write down like this. Now we know about this formula. What is the formula? X cube plus y cube plus z cube minus 3xyz is nothing but x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So now if we multiply these two terms, the answer is this. So we can write down this can be written as the product of these two things. And now since this and this is common, so we can cancel them and we have only 3 upon x plus y plus z. This is the value of del u del x plus del u del y plus del u del z. Now we want to find out the value of del del x plus del y plus del z whole square of u. So this is our left hand side. Now we can write down this in this manner. This is a square del x plus del y plus del z whole square. So we can write down 2 times and the u is operated in the second part. So del u del x plus del u del y plus del u del z. And we have already obtained what is the value of del u del x plus del u del y plus del u del z. This is nothing but 3 upon x plus y plus z because we have already obtained this result. Now let us try to find out the simplify this one. So we can write down del x of this, del y of this plus del z of 3 upon x plus y plus z. Now now we consider x plus y plus z as only x. So what is the derivative of 1 upon x? What is the derivative of 1 upon x? This is nothing but minus 1 upon x square. So clearly here we can write down the partial derivative of 3 upon x plus y plus z is nothing but minus 3 means minus 3 is already over here, minus 1 upon x plus y plus z whole square, and again derivative of x plus y plus z with respect to x is 1 plus 0 plus 0 which is 1. So now what is the partial derivative of 3 upon x plus y plus z is 3 minus 3 upon x plus y plus z whole square. Similarly, if you find out what is the partial derivative of 3 upon x plus y plus z with respect to y is again minus 3 upon x plus y plus z whole square into 0, 0 plus 1 plus 0 which means 1. So this is minus 3 upon x plus y plus z whole square, and similarly the partial derivative of 3 upon x plus y plus z is minus 3 upon x plus y plus z whole square. Now since the denominator is same, so we just adding the numerator. So minus 3 minus 3 minus 3 will become minus 9 upon x plus y plus z whole square. And this is our right hand side. Hence del x plus del y plus del z whole square of u is equal to minus 9 upon x plus y plus z whole square. This is the desired result. Thank you.